Good morning, everyone, and welcome to today's session. So, we are going to start shortly. In case anyone is having any issue, please let me know. Pratik is asking, good morning. I have a question. Do we have to do the putty configuration every time we need to start the vagrant? Pratik, normally, whenever you have created a machine with a vagrant for logging inside the machine, you need an SSH client. If you are doing this on Windows, okay, then only you need to configure the putty. But if you are doing it through a Linux or Mac machine, then you don't need to configure putty. You can directly do the vagrant SSH. It will take you inside the machine. No need for any PEM generation, sorry, the PPK generation or the putty configuration. Abhilash, if booting is not occurring, that's because your system right now, the BIOS of the system, there is a virtualization enabled. Okay, so there is a virtualization option both for Intel and AMD. You need to enable inside your BIOS, and that happens during the booting of your laptop. Okay, so you will first have to enable it, then only you would be able to use the virtualization, because this is a virtualization technology. If the hardware, if it's blocked inside the BIOS, you can't use the virtualization. Okay, so Soham is asking, can you please go over the Vagrant uses and its purpose for DevOps automation point of view? So Soham, the main purpose of Vagrant is to provide you a test or development environment. Okay, whenever you are writing something, you need an machines, okay, VMs to run the configuration and test that out whether they are working or not. Okay, so you can easily create a disposable environment using the Vagrant, test your configurations. Once everything is working, you can destroy the VMs, and this is how that's the main use of Vagrant. Okay, and that's how we are also using it. We are creating the machines, performing the labs, and then once we are done, we are destroying it, right? It's just a way of providing you the easily the VMs. Okay, and from the DevOps perspective, you have to test a lot of automation, so you can create them using the Vagrant and test it out and then destroy it. It's an inexpensive way of getting the VM. Yes, Pratik. So for Windows, you will have to do it every time. And for Windows, even if you are working in an corporate environment, and every time you get a new key, okay, you will have to do this. Okay, same steps you will have to perform whenever you get a PEM file. Janish says, hi. Bala is saying, do we need to do the PPK generation for VM? The exercise of PPK generation we have done for VM1. VM2. Yes, Bala, every time, see, Vagrant automatically places a key inside the virtual machine, okay, through which you can log in. And every time that key changes, so you will have to do it every time, okay, if you are on Windows. But the people who are on Mac and Linux don't need to do that. Abhilash, during the boot time, okay, uh, you have to press F6, F11 depending upon your laptop. So you can just search it out based on your which laptop version you are using. Okay, it shows you how the option. that to open the BIOS, you can press this key, it will open the BIOS. But that the window is very small. Okay, so you within after starting within few seconds you will have to click. Otherwise, the booting happens of on your laptop and your OS is loaded. Inside that, you will have an advanced option. In that, there is a virtualization option over there. So you will have to search it for your laptop how to enable. Just take the whatever laptop you are using. Okay, whether it's Dell, Windows, anything, just check for that how you can enable the virtualization in it. Just verify that your virtualization is enabled, okay, and then you would be able to boot inside the through Vagrant. And every laptop provider, each company is having a different set how do you log in. Some are using F6, some are using F11, and so on. Abhilash, where have you checked it's enabled? Anyone who is having this sort of issue, you can share a screenshot with me, okay, or you can mail me. I will help you out over there, okay? Because if we keep on troubleshooting, we won't be able to proceed ahead with our. So just drop me a mail, open a mail, and drop it to Cognitia support team. They will redirect the mail to me, okay? So, okay, like Bala has said, okay, he was also facing the same issue, and he is saying that he enabled the virtualization from BIOS, and all the issues which he was facing yesterday were resolved. Okay, guys, please make sure the virtualization is enabled. This is from a hardware end. You understand, software only works when the hardware supports it. But if that functionality is turned off inside the hardware, you can't really run the software over there. Okay. Samiksha, that's what we are saying. See, when you say it's starting from yesterday, where it's stuck right now, it's not booting, it's showing boot, and it's not booting. If it's not booting, that's because of the issue that I just told you, that the virtualization is off. So you have to go inside the BIOS and enable the virtualization. Depending upon your laptop provider, you will have to search in Google how you can enable the virtualization. Yes, Samisha, I got it. It's stating booting endlessly. That's the issue. So depending upon what laptop you are using, just do some Google how to enable the virtualization in your laptop and provide the version. It all the steps will come. Then you can go ahead and enable the virtualization, and you would be able to boot the virtual machine. Otherwise, the booting will not happen. So Janesh, if the timeout error is occurring, okay, you will also have to verify the same thing, the virtualization. And if the virtualization is enabled, then let me know, okay? Drop a mail, and I believe today is Sunday, that's why they might be having an off today, okay? Don't worry, they will redirect the mail to me. Sujit, you can use the RHEL as well. Just search in the Vagrant Cloud, okay? Like we did yesterday for the Red Hat Linux, but there is issue with the license. You won't be able to update the packages and all. So that would be an issue. Guys, I would suggest whenever we are doing the lab, okay, follow exactly the same way. Use CentOS only. Otherwise, what happens is you are doing it for first time. If you start using other operating system, you are right now just getting familiar with the technology. There are different issues might come up, okay, and instead of focusing on the tool, you will be struck only on the OS side. CentOS is a very broader like operating system. once you get familiar with the tools, okay, once you are confident enough how to make them work, then you can install anywhere. Okay. So you might be having a dev environment, okay, but there won't be any dev environment to run your playbooks like the configuration management. Okay, so dev environments and the staging environments are there for the developers, not for the DevOps. People are not running their ad hoc playbooks like that. Okay, those are for the application if you are talking about. How can we confirm that the required setup is available on VMs? What required setup is available on VM? So Pratik, were you able to make this work yesterday after enabling the virtualization? Yes. Okay. So two people were able to resolve this. Okay. And here is a link which Pratik has shared how to enable the virtualization. Okay, in their laptop. So just have a look at this. If this works, okay, this is something which Pratik used yesterday, and he was able to resolve it. Okay, all the people who are not able to boot, who are getting timeout issues, kindly use this link and verify that the virtualization is enabled. Okay, Sanjit, this is something which is done by the QA. When we are going to do the build and release, then you will understand how you can make sure that the build and code is available on the test machines. Okay, we haven't done the builds and release part yet. Okay, all right, so let's start with the Git now. Okay, so Janesh, I would suggest that you should always type in the commands, okay, rather than copy and pasting that. This is because when you copy and paste, you don't really learn anything, right? And you will not even remember any of the things. When you type in the command, okay, the more you type, the more you will remember everything. And you will have the question. If you just copy a command, I can provide you everything inside the notepad. I can provide you the history, okay? But then once you copy and paste it, you will not remember anything. Soham, if you haven't created a virtual box, how will you perform the labs? As simple as that. You might have a separate Jenkins server, you might have a separate Nexus server. Okay, how do you perform the lab over here? Whatever we are doing, how do I show you practically? And when we come down to the like Ansible, the Puppet and Chef, then it will sure. Let me unmute you. Unmuting you, Soham now.
Are you able to hear me now?
Yeah.
Okay. So my purpose of this question was that not about the virtual box that we are going to do on our laptop for the lab setup or the learning purpose, But you see, my question stands from an enterprise point of view. See, if I'm working in my organization and I stand as a responsible person to get one particular application or two particular applications automated from ST, SIT till production. And so my concern stands, where is Box as an application helping me out over there? As in, if it is just for my personal knickknacks or whatever I want to do on my machine separately, for that understanding, is it just for that? Because I have a separate team altogether who provides me with server on which I want to install the automotive applications. I have Jenkins set up with slave machines on altogether different servers. So suppose I have one Jenkins machine or one main server for that, and I have three separate servers on which my slave Jenkins are running. In that case, where do I need Vagrant? Where do I need a box, separate box, which Vagrant helps me create? So how
Okay.
does help Vagrant is helping me out over there? Are you able to understand my question?
Yes. So,
Yeah.
Soham, let me tell you, when you have to automate from dev to production, okay, so you are going to use, there are two of the things which you can use. First one is the configuration management. If you are working on VMs, okay, and if you are working on containers, you can use the Docker. Now, the main part comes that whenever you are writing a configuration management tool, okay, let's say we have written something like for a generic CentOS based system, we want to install the Nginx, we want to deploy our web application on the Nginx, and we want to set up the proxies and deploy the Nginx code so that everything works seamlessly. Okay. Now you are going to write all this automation in, let's say, Ansible you are writing right now. Okay. Now you have written this in the Ansible, and now you have to merge this code. Okay. So that you can run everything seamlessly in dev environment, then to stage environment, and then to prod. You have written the automation. Okay. The very first thing comes that obviously you can request a machine with the team that you are saying, but not all everyone is getting that sort of freedom where they are creating the machines. And even in the public clouds you will see that you have to pay extra for every time you are creating a machine. So the virtual box is only helping you out in the case if you need a disposable VMs, and that's something for writing the automation or testing the automation, because you have to test it somewhere. If you are already having a testing like VMs on your disposable, then in your case you might not require. But usually what happens is then you will have to copy entire like your code which you have written on those VMs, set up Ansible there and everything. Although you have already done it on your local laptop, but still you will have to repeat everything there again and then test it. So that's a one way of doing it, but not everyone is having the that kind of functionality. And see, the question comes when there are 12 people in your team. Okay, so are you creating 12 extra servers just to test out, and your company is providing, like, I might need at least 3 servers and there are 12 members, they need 36 servers. So are your company providing you with the 36 disposable servers? If
No.
yes, then it makes sense. Otherwise, see, that's why the virtual box came into effect, that each of the 12 individuals can have virtual box on their laptops and they all can test simultaneously without affecting the other one, right? Otherwise, if let's say there is a single machine and 12 people are testing, then your code might get affected. Someone needs Ansible 2, someone needs Ansible 3.6, different version might be there, or he has written a code where he is overriding you, right? So it sort of creates a mess. That's why the Vagrant was there, to create a test environment on your local VM, and so that you can test everything. And it's quite fast, right? You saw, you just need to run the Vagrant up. You can save this that Vagrant file, and every time you run a Vagrant up, the environment is ready.
Right. And one more question regarding the Vagrant, that whenever I destroy a Vagrant box, that means whichever application like Apache or the entire stack of application whichever I have installed are all going to get flushed out, right?
Yes, so everything is going to get destroyed, and next time that you run Vagrant up, then it's going to create a fresh VM. If you want, you can stop the or like halt it. Okay, don't destroy it. In that
Like
case,
suspect.
it only stop it.
Okay.
Okay, all right.
Okay. Thanks.
Okay, anyone else having any question, or should we start with the Git now? All right, so let's start with the Git now. Okay, now the very important thing inside the Git is to understand how the Git actually works. Okay, when you are using the Git commands, you will not recognize. If you don't understand that, you will not properly able to relate with what's happening in the backend. Okay, so try to focus on this part. This is the most important part in understanding how the Git really works. Okay, all right. So the very first thing is understanding the three environments. See, this is our own laptop, okay, where we are going to work. So just a second, let me take the pen. Okay, we are working as an developer A. Okay, you can think of it like a developer A or DevOps A. It hardly matters because both the way of working of the Git remains same for both. Okay, now so this is our laptop. Okay, and now whenever you are working in your laptop, you will be having when you have installed the Git, you will be having basically three stages. Okay, first one is your working copy, another one is your staging area, and third one is your local repository. Okay, now this is not something which is like partition in your laptop. This is a logical constraint of how the Git works. Okay, so this is something logical. You won't be able to see this area in your laptop like that. Okay, so initially what happens is whenever you are writing some form of automation, so you will be writing the various Ansible playbooks or Puppet or Chef. So you are going to write a lot of configuration management. You will be writing a lot of automation. Okay, or and then there are scripts. There are a lot of things through which DevOps can automate the environment. Okay, so whenever you are writing, whenever you are creating a files, at that time you are basically you will be having a working copy. You are in this stage. Okay, so very first time you are here when you are actually writing the code. Okay, you are working on it and you are creating a working copy. The next stage comes, like I am having 100 files to be edited. Out of that I have completed like 10 to 12 files right now. Okay, and I have to complete around 25 files more before my automation is complete. Okay, let's say that. So out of those 100 files I have completed 12. I have to complete 25 more. Okay, but I know I have completed 12. So I don't want to keep them in the working copy because I might forget which files I have already edited. So it makes sense to move them inside this staging area. Okay, so next part comes is your staging area. So you can see editing of the files was completed. I know this is the finalized file. Okay, so for the temporary part I can move them from working copy to staging area through git add command. Okay, so you can run git add. Okay, if you run the add command, it's going to move from working copy to staging area. Okay, remember that. Still both of them are temporary. Okay, you haven't made the changes permanent, so these two are temporary right now. Okay, now I can work on rest of the 25 files. When I have done working, I can move them from working copy to staging area. Okay, and see, so how do you change? Very first thing is it goes like this. uh, uh, Once you have the files in the staging area and you are done with the editing, now everything is done. We don't want to edit the files, we want the files to be permanent now. Okay, so you can move it to your local repository. Okay, I will tell you what this local repository is, but now from the staging area, you can move them inside your local repository, which is on your laptop. Okay, remember, you are every person, this is some other person on your team. Okay, developer B, he is some other person, he is also having the same local repository on his laptop which he is working, right? Might not, this local repository can differ from your local repository, this is locals to your laptop. Okay, and his one would be local to his own laptop, right? So everyone is having a local repository. So once you are working, you are in working copy. Okay, and then once you are done editing, you can move it to staging area through add command. And once you are done editing everything and you want everything to be permanent, you can commit it. Okay, so we can run the git commit command, and that will move the files from staging area to local repository. Okay, remember that. So git add moves the file from working copy to staging area, and git commit moves the files from staging area to local repository. At that point, your files are committed. Okay, and you can know, it's like a permanent changes that you have done at this point. Okay, and if in case you have to change something again, then you should again edit them. You will reach out to working copy, again add them, again commit them. Okay, Pratik, what this question means, where does the git gets the memory to store files in staging? See, don't relate it with memory and something like that. That's internally managed by Git. Okay, so memory is available for at the Git disposal, right? You don't have to don't try to get into the coding side, right? How it's storing the arguments or variables or integers, things like that. Just understand the core concept of the Git, because how does it store it doesn't really matter to us. Okay, do we have to configure these specific areas while installing Git, or are they configured automatically? Vishal, as I said, this is a logical constraint for your understanding how the Git works. Okay, there is no such thing like creating these areas or something like that. Whenever you start editing a file, you should have in your mind an understanding that right now you are in your working copy, and then you will have to move to the staging area, and then you will have to commit them and move to the local repository. This is for your understanding why the add is there, why the commit is there. Okay, this is a logical, no such thing actually exists inside the git or on your laptop. This is how the git has been constructed. Okay, that's an architecture for the git. Okay. Yes. So Sanjay is having a question. That's why I was discussing this thing. So his question is, what is the role of staging area? Why can't we commit directly to the from working copy to local repository? Okay. Sanjay, the thing is, whenever you are going to make the changes permanent, okay, and whenever you are writing a code or writing a configuration, you have edited so many files. Okay, you want to relook before committing, because any wrong changes that you are committing can make your production go down. Okay, so and your applications can go down. Okay, in case of developer, so they don't want to commit the wrong changes. And since they have to deal with so many files at a time, okay, so it makes sense that you first figure out your changes, move it to a staging area where you can review all the changes. Okay, you know what changes you are going to commit. Think of it like this: if you are trying to commit directly from working copy to a local repository 40 files, okay, and some of the files are still pending and you commit them, then your application might go down. So Git decided that it should have at least two areas, that is a working copy and a staging area. Once initially you start with working copy, move it to staging, have a review. Okay, look out for the things in the staging area, that whether they are finalized or not. if you still want to make some change, it's possible that to revert back from staging area to working copy. Okay, until and unless you have moved to the local repository, nothing is final. You can still make the changes. Okay, make sense? All right, and Manoj is saying, if I add one file to staging area, then can we make any changes in same file after add to staging area? Okay, so Manoj, in that case, once you have made the changes to the staging file, if it hasn't been committed yet, you are free to make further changes to that file. Okay, and then you can again move them to the staging area so that your changes would be reflected. Unless and until you have committed out the things, okay, they are not finalized yet, you can edit them again without creating a commit ID. Okay. No, Janesh has a question. Developer A and developer B files are assigned beforehand. I mean, they work on separate files, which is known beforehand. No, Janesh, that's not a necessary thing. Anyone can work on any file. Okay, it's the responsibility of the Git to track. There shouldn't be any collisions between the developer A and developer B. For that, there is Git will raise out conflicts. We will come down to that as well. Okay, but remember that developer A and developer B, both the individuals can work on any file that they want. There is no limitation like that. So Manasi is saying, this does commit is reversible? Yes, Mansi, the commit is reversible, but that's for the later part. For now, just treat the commit to be uh, it's a permanent sort of thing. Okay, you will be issued a commit ID and things like that. Obviously you can revert everything. See, it's a software that we have created, so we can revert it back. Okay, no one is, it's not creating a blocker. But for most part of the understanding, remember that whenever you are issuing a commit, you should be cautious enough that these are the permanent changes that you are doing. Because when you revert a commit, okay, if you have already pushed and other people have also merged it and then you revert it, so the overall history of the project gets disturbed when you revert back the changes. And if you have you have reset hard, okay, then eventually everything is removed, right? So that's a complex sort of thing to revert a commit, but don't go there. For now, just treat it like the commits are permanent. Okay. So Bala is saying, even if we commit until the QA is done, changes will not be taken to the production. Yeah, so yes, Bala, that's a case for the developers. Okay, if we talk about the DevOps, we are not having any QA person, okay, to test our changes. Whenever you are making a changes to the configuration management, you are the only person who is going to be responsible for that. There is no QA team for the DevOps. Okay. Yes, Sridhar, you are right. So staging areas usually show what changes were made, and it will help you to review what files were modified or added and what you are going to commit now. Okay, so you can have a relook to those files. No, no, Soham. If Soham's question is, suppose if my laptop is destroyed after add and not committed yet, will I get my code back? No, Soham, you will not get your code back. Okay, because that was on your local laptop. I will show you how you can get your code back. Okay, but in the case that you told, in that case you won't be getting your code back. Okay, now one thing is, here is a state change and commit changes. So what happens is, it works like this. Whenever you are working in a work copy, then once you are done, you will cause a state change. In that case, it goes to the staging area. Then you will issue a commit, which we were talking about. Okay, and it will go to the local repository, like that. Okay, it goes here, then it goes here. into the staging area, it then you issue a commit and it goes to the local repository like that. Okay. Now I hope the working copy, staging area, and local repository is clear to everyone. Okay. Soham, I will answer those questions in just a while. Okay. First of all, let's complete this architecture and understand how it works. Okay, that was on the local laptop of developer A. Now, very first thing, how now this is a remote repository. Okay, this can be your GitHub, Bitbucket. Okay, they are the most famous one, or you can install GitLab on your own server. Okay, now this remote repository is allowing the two developers to communicate with each other. So someone is unmuted. All right. So here is a remote repository. Okay. Now this remote repository, okay, is there to help in the collaboration between the different developers. So what happens? See, very first time that you create your local repository, you can create it from the remote repository. And this remote repository is actually the source of truth. Okay. So what is the source of truth? See, when whenever there are multiple people working, okay, you need to have one repository which will always have the latest code. Okay, and everyone will take a reference from this repository. Okay, so whatever code is inside this remote repository, we will take this to be the truth. Okay, and this is our finalized code. So anyone wants to edit something, he has to take the code from this remote repository. Okay, so when he is starting up, what he can do is he can fetch he very first time. Okay, that use let's say we just joined an organization and we are right now creating a repository. Okay, we as a new developer or DevOps person, very first time you are working on it, then very first time you will have to clone it. Okay, you will have to clone this repository. Whenever you clone a repository, okay, the same repository, whatever code is inside this remote repository, the same code will come down to your local repository. Okay, to this laptop, entire laptop. Okay, you will have your code here, which will allow you to work in your local repository. Okay, so very first time you are going to take a clone. Now whenever you are going to start the work on your repository, the best practice is to always fetch, okay, and pull the latest code. So it goes like this. You should always follow this path. Okay, before editing any of the file, if you want that the conflicts are not there, what are conflicts I will shortly tell you. Okay, but you should always take a pull from the remote repository into your local repository, so that if anyone else has made any changes, you are always inheriting those changes. Okay, because if you make a change over their change without having those changes, then it will result in a conflict. Okay, so you can pull the latest changes from the report repository into your local repository using git pull command. Okay, and once you go to the working copy, you have done with your changes and you are having all the changes committed inside your local repository. Now you will have to push those changes. Okay, you will have to push these changes into the remote repository, so that other people can have whatever changes that you have done, can also have those changes. Okay, and once you have pushed it to the remote repository, okay, they will get merged here inside the remote repository. Now this is holding your changes as well. So now if developer B is there, he will have to clone this repository. Okay, and he will eventually have to pull the latest code. Now the latest code will be here, and he will again do his own changes and push back. Okay, so this time you can pull their changes. This is how the collaboration between developer A and developer B happens. Okay, and this not only between two individuals, any number of individuals, let's say 12, 15, any number of individuals can share their code like this. Okay, Now let's take on the questions. Okay, so Soham says, then what is the use of distributed version control system? Why not use a centralized version control system? Okay, so Soham, let's discuss about your case. Okay, so you are saying that you have added the files inside the staging area. Okay, so you should have committed the changes. Okay, at the end of the day, or in middle of the day, if uh, you are worried that your code can get lost, then what you can do is you can create your own branch. Okay, the strategy of branching I will shortly discuss. Okay, but you can create your own branch inside your local repository and your remote repository, and then at every day you can push your code in your own branch. Okay, branch you can think of for now, just think like you can push your code at an isolated place where it is not going to affect the production running code or other people code. That's a separate area inside the remote repository where you are only working because you have created that branch. No one else is worried about that branch. Okay, so what you can do is you can push your entire code over from here to the remote repository in your branch. Okay, and that's how people actually use in the distributed version control system. Now if your laptop crashes, okay, this goes down, then you are still having all the changes in your remote branch, and you can pull that back to your new laptop that you get, so all your changes are safe. Okay, the advantage of working like this, okay, the very first thing is developer A and developer B can share the code between themselves as well. Okay, because if they don't want to go through the remote repository, let's say he wants to review his code, he can do that. Very first thing. Second thing is it allows the multiple repository to be created. Okay, see, one repository is here, another one is on the developers or DevOps side. Okay, so you are having a multiple repository right now. It's much faster. Whatever commits you are issuing, you don't have to wait or changes will not happen over the network as in case of centralized repository. Okay, which are usually somewhat slower, and you need to have a dedicated network connection between your machine and the remote repository. If you have put something like the IP whitelisting, okay, then it will not allow you to work on your local repository. There is no concept of the local repository in centralized repository. In this case, whenever you commit a change, it would directly go inside the remote repository only. Okay, so think like this: you are working from home, okay, and your company has whitelisted your IP in the remote repository for the security perspective. Okay, so whitelisting of the IP has been done, so you can't work, right? Unless and until you go on to some VPN or something like that, you can't really work. But if you, let's say you are at some place and you are not having the access to the VPN, so you can work in your local repository. When the internet comes back, you can push the changes into your remote repository, and it's pretty much faster. Multiple copies are being maintained, you are having your separate branch, so you can work. It's an additional advantage, and two people can share. But in case of centralized repository, it will not work. Yes, Soham, if you haven't committed the changes and haven't pushed those changes into the remote repository, then you will actually lose out. Okay. But it allows you to create your separate branch, so you can easily do that. There is no stopping from that. Okay. So Janish says by local laptop, you mean local VM and virtual box. So Janish, usually what happens is yes, the very first thing is that it might be your own local laptop, okay, where people actually develop the code, okay, and write everything because they, uh, this is where you will write everything initially, and then it can be some uh, center, some server as well. If you have created a server where you are, everyone is going to write that code, okay, Normally, in case of Ansible, we are having this one server, okay, where Ansible code lies, and everyone copies the code inside their home directory and work over there. So it can be anything. It's just a machine where you are going to code, okay, or put your configuration. So I mean that by local laptop, okay. Sure. So just a minute. I will unmute you, okay. And what is the difference between pull and fetch? Okay. See, while the fetch makes everything between your repository and the remote repository exactly same, like if you have created a branch, okay, which is not existing on your local repository, but it's on remote repository, then the fetch will bring that branch as well on your local repository. But if you are issuing a pull, that will update the latest code inside your repository, a local repository, to same as that of the remote repository, okay. So all the latest changes, you can issue a git pull and it will get all those changes from the remote repository into your local repository. So Vishal has a question: push changes from local repository into remote repository with git commit command. Again, no, Vishal, the pushing of the changes happens through git push. Git commit moves the file from staging area to local repository, okay. If developer A and developer B push the code on same time, what will happen? It will result in a conflict. Okay, we are going to get down to the conflict shortly. Okay, but for now, just remember that if they both assign a different value. Okay, so what is a conflict? See, what happens if, let's say, developer A assigned a equal to 1, okay, and he has pushed this code inside the remote repository, and now he has merged his code, but the developer V didn't take a pull and he has now assigned a value of 4, okay. So what value should it be, whether a is equal to 1 or a is equal to 4? Git will detect this, okay, and raise out a conflict saying that both the people have assigned a different value, because a can't be 1 and 4 at the same time. Their a would be 1 or 4, so they have to decide between themselves whether it's 1 or 4, okay, and then only it will work out, okay. And so Bala has a question: do we cover how the integration will be established from different developers code? Bala, I will show you how you are going to commit and merge the code. Okay. So that's, I believe, merging of the code you are saying about the integration. When we come down to the branching, then I will show you. Soham, I will unmute you shortly. Let me answer other people question, then I will unmute you. How push and merge are different conceptually. So merge, I will tell you when we come down to the branching strategy, because unless and until I clear you about the branch, what is branch, okay, you will not be able to understand the merge. And for the push is simply when you are done with your changes, you will push the code from your local repository into the remote repository so that the other people on your team can take your code now, okay, because they will also have to have your code which you have pushed, okay. This is how the everyone will push their code at the end of the day when they are done with the coding, okay. Git fetch from remote branch to local repository, yes. Nikunj, that's what happened. So Git actually fetches the everything onto the remote repository and creates everything the same into your local repository. Okay. If there is a conflict, how it is communicated to the team and how is it resolved? So Janesh, whenever there is a conflict, okay, you would be able to see in the remote repository, okay, the conflict details. And other thing is, whenever you issue a pull, okay, whenever you are issuing a pull command here, okay, it will show you, it will, git will error out saying there is a conflict. Okay, and unless and until you resolve that conflict, you can't download further files. It will stop downloading further files, and you will have to resolve this conflict. Okay. Arun, I will tell this after some time. Okay, we are going to conflict, how we are going to resolve the conflicts and things like that. Okay, but for now you just need to understand that a conflict will stop a further downloading of the file, and you will have to resolve the conflict to move ahead with working. So very first thing is everyone clear now about how you can work within the about this git workflow? Okay, Soham is pending, let me unmute him. Okay, he was having some question. All right, go ahead, Soham. Now I have unmuted you.
Thanks, Ankit. Ankit, there are actually I have worked on centralized version control system, which is SVN, I believe. So,
Okay.
so I need to understand actually how does distributed stands different from SVN, because I mean the centralized, because there are only one or two scenarios where I can find me upgrading to distributed, that is JIT or GitLab or GitHub. Um, Only very few advantages, which is practically not necessary. Such as, suppose the first scenario being, um, I have given the documents on which I have to work for the weekend or for the week off that I've taken. It's a 1 week or 2 week long holiday that I'm on, but I still have to work, right? I still am given with the works. So while doing so, unfortunate, I am not connected on the network, company network. I don't have any internet. And for the day of the work, I did not even commit it.
Okay.
And I destroyed my laptop by spilling water over it, which becomes a huge issue because I was the lead, or I mean, I was working on a very important code, and now I don't have it. I don't have the entire um, code with me, and whichever I have worked with or worked on, it was pending on the staging area, and now I come back to the office. This just happens one day prior to my coming back. I come back as soon as possible and I discuss the scenario with my manager, and I was about to lose my job. So, uh, and this was a scenario which has happened to a colleague of mine, a
Okay.
very
Yeah.
area, a very important financial development which was to be propagated to production in a day or two. Uh, but which the work which was done over the weekend or a period of week was now lost, and since it was he was not able to connect to the repository, uh, remote repository, so he was not able to get his stuff back. In such
Okay.
scenario, how is it different? How is JIT different from SVN? Because even SVN wouldn't have allowed me to commit it to the centralized repository. Over here, JIT did not allow me to commit it to the remote repository. Whatever there was, it was on my laptop, and my laptop is now water.
Okay. So see, the very first thing here is, Soham, like if someone has whitelisted and you are not on their network, obviously you can't, uh, you know, push your changes into the remote repository. Okay,
Right.
but there is a workaround for that. Okay, there are remotes. Okay, if when we go ahead, I will show you. There is something low known as origin and the remote. Okay, so if I uh, run this command git remote -v, okay, and it will show me all the origins where I can push my code. Okay, and suppose you have such an important commits and in your repository, and you are also worried that something might happen. Okay, So better way is like, because you can't push it into the official repository. Okay, you can, but you are having some private account, or those kind of accounts where you are having a repository where you can push down. Okay, uh, might be your own repository or something like that. Okay, which you are running. So you can remove the origin, change the origin. Okay, Git
Hmm.
allows that. So it will allow you to change the origin, and then not on your official repository, but to some other repository on the remote, you can push this. Okay, now
In
even
this
if you're,
I'm sorry to interrupt you. Actually,
yeah,
this scenario cannot be successful. Like, I can use private, I mean, public network is what you're saying, is it? To
no,
save
I'm
my.
not saying the public, entirely public. You can, it's up to you. See, there are two things. The very first thing is, if even you are using a public repository, it allows you to create the private repository, which is only available to you. Okay,
Definitely, definitely. That is the scenario
and
that I'm talking about.
right.
Unfortunate if I'm caught in this mess, because I have to submit. I mean, the person who does this, he has to submit his laptop for annual this check. And,
Okay.
mm, and PwC. I'm sorry to take names of the
Yeah,
company,
yeah.
but
See, I understand that you are saying about the compliance framework.
exactly, exactly
Okay.
that. Compliance, right? I would be thrashed very badly because I'm not supposed to keep the code, working code of my company in any other place apart from the given scenario. In fact, the code from my SVN had to be moved into it, and the code on the SVN server was all deleted, and no copies were kept because that was now getting the shadowed, and then SVN server was now getting removed, and no separate copies apart from the working copy or the working servers. We were allowed to keep the code on.
See, so at this point, I will tell you that what happens is it depends upon company to company. Okay.
Hmm.
If you talk about a financial company, everything for them is security. Okay. Due to which you are having less flexibility. Okay.
Right,
So SVN kind of this versioning system makes sense in a financial company where you are going to be more cautious, you have to follow the security. But if you come down to other companies, like someone working in education sector or others working in e-commerce, okay, they have to do like lot of commits, and there are no such stringent checks. Okay, even if you see lot of see, I have never seen a financial company keeping their code on the remote repositories like GitHub or Bitbucket. Okay, they will create their own repository like GitLab, sorry, and
right,
they host their own repository. Right now,
right.
so I would suggest that from a project perspective, there is no denying. See, distributed repository just provide you with some functionalities. You might or might not use them. That's why Git is not entirely. It's not that the in the entire market the Git is being used. But whatever you are able to achieve with the centralized repository, you can achieve through the distributed repository like Git. The very first thing, because it's allowing you to push the code and everything is here. Okay, and you are maintaining your own copy as well. You can
Right.
share between different developers as well. You can change the origin, push it to anywhere you like. If you are not on network, still you are able to commit inside your local repository and keep a track of your work. When you connect to the network, you can push there. Okay, without affecting any compliance or anything like that. Okay, but let's say this is an issue, your company don't want that different repositories to be created due to the compliance issue. They don't want anything to be kept on your laptop, because obviously your laptop is not much as not secure as their servers and their environment is. Okay, so
Correct.
it's completely understood. In that case, no one will ever say that this the Git is more suitable in that case. No, in that case centralized repository is more suitable. But what I have seen is then that when large number of commits are being issued, okay, then there is some individual in between who is actually sitting there to handle those kind of commits. let's say within a team of 50-60 people are there, okay, and they all are making the commits inside the centralized repository. The chances that the two people are doing the commits at the same time is very high into the same file, and because
Definitely.
everything is pushed into the centralized repository, a lot of conflicts will be raised, okay. While if you were working on your own branch, okay,
Mhm.
then you would, before merging, it will report you an conflict and you won't go ahead, and it would be much easier to maintain the fresh, like the working copy of the code, because not everything is being pushed in a centralized place without reviewing. And then there comes the review part, okay. See, whenever you are going to merge the code, you can open for a review and someone else in your team can review your changes before you actually merge them. Now what is merging, I will come down to it somewhat later, okay. But merging is an another benefit that you can take and someone can review it. See, it all depends upon the process which you are following, okay. So I
Right.
would just suggest that depending upon project to project, the distributed repositories and centralized repositories make sense. Another thing is, no such thing is like there that the SVN can do and Git cannot do, and Git can do, SVN cannot do. It depends upon the, like, your overall goal which you are trying to achieve, okay. Git has gained this advantage because it's a lot of flexible. It is having all the functionality of SVN, though it is having some additional functionalities. Like I said to you, that you can change the origin, you can keep everything in local repository, you are maintaining multiple repositories. So if something happens to your remote repository, let's say this server crashes, okay, so what happens? We are taking a case in SVN that this will never crash, okay.
Correct.
But hardware
Correct.
failures are always there, right?
Definitely.
Then it will become more hard for you to recover this, okay. You will have some backup strategies and everything like that. If somehow that backup is not working, you will lose out code, and eventually the person who is managing this repository is doomed, okay. So
Right.
in that case, if you were on here, you would have pushed the code, you have created another repository, okay, here, and you would have pushed the code from here to here. See, this is an additional advantage, right? You are having multiple copies of same repository.
Correct.
So everyone, there are advantages and disadvantages to all the approaches, okay. So depending upon the project, I would say you should select the type of repository to be used. But obviously in a
The fear.
financial domain, SVN makes sense because they don't want their code even to be on the local laptop, right? This is not safe. I won't ever, any day I would not say that this is entirely safe. They try to make it safe, but then eventually you can download something which is not safe,
Right.
okay.
Um, um, Almost actually. Actually, recently, since I am working in a project which is partially financial as well, they're trying to enter into banking, but they are using GitLab.
Okay. Yeah,
Right.
so GitLab is an inexpensive way. See, it's an open source, first of all, and it allows you to keep everything on your own network. Now, your network is isolated from internet, right? So it
Right.
cuts down on the security, that everything is secure in your own network and no one else is able to access even that repository. So security increases in that case. I have seen companies managing their own code, like repositories, okay?
Right, right,
And
right.
then,
It's a huge financial, it's a huge financial company, I would say, and they can do whatever they want. I mean, they are in a position where they can do whatever they want. They have huge investments, so they have multiple servers. The infrastructure is huge, so they don't have any issues with keeping their own private, um, I mean, repository on private network. But the thing is that they were using SVN, and the parallel team of mine, the DevOps team, they convinced them to not use SVN anymore and jump onto GitLab because it seems they had convinced them that GitLab is somewhat more useful or user friendly than SVN. I
yeah,
partially I intend to know that why is it so that I mean the entire the entire Apex decided that uh, GitLab is better than SVN, and every every application lead had to configure the code on GitLab and cast out
okay.
SVN.
So in GitLab, you will see. that it allows you, it GitLab is comes down with a lot of functionality, and that's inexpensive functionality. If you use the GitLab is having their own CI. Okay, so you are getting a CI CD implementation inside the GitLab for free.
Hmm.
Okay, it can do that. You can implement the hooks, and the entire DevOps framework can take a kickoff if you are using a GitLab CI. Another thing is, I already told you about the security. Okay, so that's also there. So see, these are the things which can convince anyone to go ahead and use the GitLab. The SVN doesn't comes with a CI CD implementation. Okay, if you are
Hmm.
using a GitLab, you don't even need the Jenkins. Whatever you are pushing, it can automatically merge. Continuous integration can be achieved through it, and even the continuous deployment can be achieved through the GitLab.
Oh,
They have integrated it, right? So that's an another way. If a team is pitching for that, then you will obviously management will find the positives in that.
right, right, right. But I was unaware of the fact that GitLab does the build as well, because in my company, they are using Jenkins in accordance with GitLab. Whatever code the developer are making, right?
Okay.
They have their own community and they have their own branches in it. They're
Yeah.
committing it and then using Jenkins and
Yeah.
Jenkins build to create a separate build. I mean to create a build. I didn't
Yes.
see.
So in your case, they would be having this hooks implemented. Git and GitLab both comes with the hooks. Okay, and this hooks can, whenever you are merging inside a branch, it can automatically call your branches to initiate the build. Okay, and everything is automated now. So whenever a merge is there, it can automatically initiate the build, and you would be notified if there is some issue with the build. So you
Right.
see, it becomes seamless. And if there are some errors or something, you are doing the builds in a lower environment, not in a production, obviously.
Correct,
Okay,
correct, correct.
so it can be done.
Okay. So are we going to learn about this GitLab and how it is making the build as well?
Okay, so GitLab is almost similar to the GitHub and Bitbucket. When we
Right.
reach down to the GitHub and Bitbucket, I will explain that as well, so that
Great.
you would be able to relate with the GitLab.
Right.
Okay,
Right.
only the installation part is there. So but you would be able to relate once we cover the GitHub and Bitbucket, and so you would be able to work on anything, like whether you are working on Bitbucket, that's an Atlassian product, whether
Right.
on GitHub, that's a GitHub, and GitLab is also there, so you can work on GitLab as well. No issues with that. Okay, all right, so let's move ahead. Yes, Janish, so you initially do the git fetch, and then you move ahead with the git pull. Every time you are going to write a code, then first of all you are going to take a pull from the remote repository, and then work on your code. Okay, like that. In what way git or any repository can be useful for system server admins? See, Prasad, you are writing the code to manage the infrastructure, right? To create the builds, deployments, or even create your servers, right? When we learn the Ansible, Chef, Puppet, and Salt, then we are dealing with these server automations. Okay, so you would see a lot of code is there. In so all the code, see everything. If you are writing any scripts, any of the form, whatever you are writing in the form of code, you need to have a version control system into it. So we are going to use the git. Whatever we do, we are going to commit everything inside this remote repository. Okay, that helps to actually share the same thing with everyone, and everyone can contribute it, and you can put the comments, so it makes easier to understand everything. Okay, so Sridhar is asking, pull request will help to review by other team members before merging to different branch. Guys, I would suggest don't get confused with the merging and branches at this point. Okay, so the pull request just pulls the latest code from the remote repository into your local repository. What is branching? What is merging? I will tell this shortly when we move ahead. Okay. So Nitish is asking, can we have a QA after the content has discussed? It's been an hour and still we are on the slide. Just concerned. Yeah. So see, Nitishri, it's the very first thing is this is the entire thing within the Git. Okay. Entire workflow is around this Git. Okay. Architecture. Once you are aware about this, rest of the things are really minute. Okay. So that's why we were working on this. I hope everyone is clear here. The entire workflow for the Git, how it works. Okay. So let's move ahead. All right, so here is a workflow for you. It's a remote repository where everything you are going to start with, all the code will be inside your remote repository. Then you are going to create a local repository by cloning the from the remote repository, and you can fetch and pull the latest code inside your local repository. You will always start by working in the starting the work in the working copy. Okay, edit the files in the working copy, then move it to the staging area, and then so this is wrong. This is initially okay. Clone is being done initially. After moving to staging area, you don't clone. Okay. After that, you commit the changes to move from the staging area to the local repository. Then you push the changes into the remote repository. Okay, and you can fetch for the latest branches to be available on your local repository. Okay, and you can pull the latest code from the report repository using the pull. All right. So after the architecture, so how do you install the Git? Okay, you can install the Git using the package manager. So if you are working on a Debian based system, then you can use the apt to install the Git. If you are working on an RPM based system, you can use the yum to install the Git. Okay. All right. So once you have installed the Git, okay, the very first thing that you need to do is you need to configure your username and user email. So why this username and user email is required? See, whenever you are working on Git, whatever changes you are going to do, it would be tracked by the Git, and there should be a means where other people in the organization can contact you for the changes that you have done. So Git needs to track about you, okay, what changes you have done, and a way which people can contact you. So there is an user email through which Git can track, okay, and other people can contact you like that. Okay. So if you don't do this, then Git will not allow you to commit anything. Okay. So very first thing is to add the username and user email into the Git whenever you create a new repository. All right. So whenever you start uh, with any directory where you are going to code everything, okay. So you start by git init, okay. This is to initialize a directory that you want to track. Once you have initialized the git, then it will track all the changes to the files and folders inside that directory, okay. So you will run the git init there, and it will this is how the directory will be initialized, and git will track everything inside that directory. Now whenever you run the git init, okay, it creates a hidden directory inside that directory like .git, and it tracks everything there, okay. So during the lab part, you can check out for the git init and see how the git is tracking a directory like that. Okay. Now we start by working in a working copy, okay, of a directory. So you start by editing the files. Once you are done, you can move it to staging area. For that, you can use the git add command. Git add and the file that you want to move from working location into the staging area, okay. For that, you can use git add command. Git status is used to check the status of the directory if there are some uncommitted files, and whether they are lying in the staging area or whether you have committed it, so things like that, okay. So you will choose you will do the git status for that. Git commit is there to move from the staging area to the local repository, so it will move the file from staging area to the local repository. Now you can issue a git commit like that. If you just issue the git commit like that, it will open a file editor for you to put a comment, okay. And you can add the comment inside the git using -m after this, okay. And afterwards your message, whatever message that you are having, so you can put that inside here, okay. And it will display that message. This is a metadata, basically telling what this commit is all about, okay, what this commit is all about. So you can put a simple comment stating why this commit was done in the first place, and that's for your readability, so you will understand why this commit was done in the first place, okay. So Sanjay says, do you want us to download? Are we gonna do hands-on on git today? Yes, Janesh, we are going to do the hands-on today, okay. And you don't need to download the git, we are going to use the package manager to install the git, okay. All right, now once you have done editing the file, okay, and you want to see what is the difference like between the file that you have edited, what lines and what has changed between the files that you are having on your laptop and the remote repository, okay, that we are having in the GitHub or Bitbucket or something like that, okay. So you can run the git diff command, and it will provide all the lines which differs between your local repository and your remote repository, okay. So you can use git diff in that case. So Bala, I can show you all the lab right now, okay. And but you will never understand what's happening in the backend if we start doing this in the practical at that time. And we are not using git bash. Git bash is there for Windows, okay. We are going to install the git on the Linux. See guys, I can move ahead of this commands, but if I try start running this, you will never understand like why this is being used in the first place, okay. So just stick around for some time, understand the entire concept, and when we start doing the lab, uh, that's not much complex. See, practical is really easy because I can just add a file and commit the file. I will move to the next step. But for you, it will be difficult to understand why I am doing this. Okay. All right. So in case you are having the multiple files to be committed, like 30 to 40 files. So you are not going to run the git commit again and again. Okay, so you are not going to run like git commit file, every file you like that. So what you can do is, you can add a hyphen a flag. Hyphen a means all the files. Okay, so it will commit all the files which are in the staging area and move them to the local repository. Janesh, if you are not having a VM configured, I would suggest you to use the AWS ones, okay, which I pinged the yesterday. So you can sign up on the AWS for free and create a VM there. And most of the people were able to resolve it, okay, the issue regarding the virtualization. So Pratik was able to do, Bala was able to do. So I would suggest you to get, we just need any of the Linux machine. Okay. So get on the Linux, because Windows, I haven't seen much of the people like using the Windows. Windows servers are almost not used now. Okay. You will always find the major, like in any organization out there, normally this Linux based servers are being used, whether it's CentOS, RHEL, Debian, that doesn't matter, because Git works exactly the same way in all the Linux machines out there. Okay. All right. Now, if let's say you have, uh, you want, in a project you have added a file and you want to remove the file, then you can use the rm command on Linux, but that will not move from the, remove it from the git if you have added it inside the git. For git, it's an another version that you are creating. Okay, so how do you remove it from the git? You will run the git rm command for that. Okay, and if you want to remove the file from the repository as well, in that case you will have to run git rm hyphen hyphen cached. Okay, then it will remove from the repository as well. Another thing is, if somehow the git is not allowing you to remove the file, then you can forcefully remove the file using the hyphen f flag. So it will remove the file forcefully from the uh, git, and git will stop tracking that file. All right. Now another thing is, Git is used for storing the configurations and files. Okay, remember that always. Git is not used to store the binaries. Okay, so whenever you are creating, running a Python script, it creates a pyc file. That's a binary. Okay, and in Java you are having these class files. So you don't want to your Git to track these files. Okay, now but these are generated automatically. Okay, so the chances that this will get committed is very high. So how you, there is a way in git to ignore these files, then git will not track these files for any of the cases. Okay, so let's say you are having a file which ends in dot class. Okay, so you can put a regex inside the git. Okay, like a star, you can create a git ignore file. Okay, this dot git ignore file is a hidden file because there is a dot in front of it. Okay, and what this git ignore will do, it will ignore all the files which are ending in dot class extension. So when you put star dot class, okay, it's going to ignore all the files which are ending in dot class. Okay, this is a way by which git will ignore. So you, if there is any of the class file in your code, okay, git is not, you are not, git will not show you when you run the git status. It will not show you that the file is there, and you don't have to commit them inside your code. Okay, Pratik has a question: can we remove multiple files in one command? Yeah, so Pratik, that's possible. Okay, uh, after git rm, put all the files that you want to remove, and then it will remove it. So Abhilash, in your case you got 2200 port. Okay, because 2222 is the first port that the vagrant uses. Okay, if no virtual machine is running, if some virtual machine is running on that port, then it creates 2200 port, and then 2201, 2202, and like that. Okay, no need for comma separated. You can just put a space and keep writing, and it will remove all those files. Okay. All right, so another thing is, uh, whatever changes that you are doing inside the git, okay, whether you are adding, deleting, committing, or whatever you are doing, if there is a point, okay, if when you have added a lot of files, if you want to see what all changes you have done, what all commits were there, and how the things were working, okay, you can issue a git log command. Git log will show you the entire log of all the changes that has been done inside the repository. Okay, now this log is usually very big. If you just want to see like the commit IDs and the messages across those commits, okay, so if you will see, the git log is very detailed. So if you just want to see the commit and the message, because that message helps you understand why that commit was being done in the first place, so you can use git log hyphen hyphen one line. It will only show you that resulting lines. Okay, and another thing, if you want to even see it much better, then you can run hyphen hyphen decorate and hyphen hyphen graph as well. Okay, it will show you even better. All right, so another thing comes is that, see, whenever you are issuing a commits, okay, there are different stages of configuration or your code where you reach up to a point, and you want that you should be able to track to that commit. Okay, now remembering the commit IDs is a pretty complex task. Okay, you can't remember the commit IDs. Let's say we were releasing an application and we reach up to a level where we say that we have created the version 1 of our application. Okay, obviously we are going to continue with the development. Okay, no one is saying to stop with the development now. Okay, so how do you remember that up to that point your version 1 was created? Okay, so for that you can put the tags inside the git, and then on basis of those tags you will understand why, at what level you have achieved the version 1 of your application, or version 2, or the feature that you were trying to bring that has been completed, like that. Okay, because commit are going to go further beyond. You are going to add additional code, then you are again going to issue commits, like that. So you need a way of tracking the stage at that point, so you can put the git tag there. Okay, so let's take a break after 5 minutes. Okay, Janish, we are going to take a 10 minutes break after 5 minutes. All right, so you can put a tag using git tag command, and you can issue git tag hyphen hyphen a, whatever tag that you wanted to put. Like if you wanted to put version 1 of your application, you can put something like v1. Okay, so it would be like git tag hyphen hyphen a v1 hyphen hyphen m, and the message that you want to put, that will help you understand what this tag is about. Okay, so it's a metadata to help you understand why this tag was put in first place. So you can do that. Now if in your code you want to see all the tags which are present, okay, uh, because you might be seeing this code at a later point in time and you don't remember what tags were put, or someone else might have put some tag to help them understand at what stage was reached. So you can run the git tag command. It will show you all the tags which were present in your code. Okay, all right, and so it's possible to add the tags to the previous commits as well. Okay, suppose you done a commit and you forget to add a tag, so you can add the tags to any of the commits using passing the commit id inside the git tag command. Okay, so you can pass the commit id and then git will tag that commit with uh, till that tag it with till that commit id it will add a tag, so you can remember why that commit was being done at the first place. Another thing is, if you want to get a detail about some particular tag, then you can do git show tag name. Okay, it will relay out all these information about the tag. Okay, and if you want to obtain the commit ids, okay, so you git log, you can run the git log command and it will show you the commit ids as well. The commit id are logged inside the uh, logs inside the git. Okay. No, Vishal. See, the Git tags are being put to remember. See, there are multiple tags, multiple commits which is continuously happening. Okay, so up to a point, you would have reached to some stage. Like, let's say you were adding a new feature. So after a particular commit, you would have added the new feature, and if you want to see that let's say that code has to go into the production, so you can add a tag and tell the team that you should release the code till here. Okay, till that tag. Or you can think of it like after a particular commit your version 1 is ready to be released, so you can add a version 1 tag and then version 2 tag and like that. Okay, so tags help you understand so that you don't have to remember the commit ids. Instead you put a tag and then say that particular tag is an understanding that at that point you have attained the certain functionality in your code. Okay, it will help you understand the code at a later point in time when you are seeing your code. Okay. All right. Next comes your remote repository. Okay. So before we start on the remote repository, let's take a 10 minutes break. And once we are back, then we will start with the remote repository. Okay. All right. So I will put a timer here. All right, so everyone back now? Should we start? All right. One thing I wanted to explain to everyone is like whatever we are going to cover, okay, the commands will always be a part of it, okay. So the entire code base is around the commands, okay, and try to understand what those commands are initially doing. That's what we are covering in the theory part. If I start taking and combining both the practical and theory, okay, uh, we are not going to reach anywhere. Neither we are going to cover all the commands, neither we are going to understand all the theory behind that commands, what's happening in the backend. That's a way because uh, when you start doing the practical, okay, you are focused on the practical side more, and it's easier to move quickly ahead using the practicals. So if you want, I can move ahead with the practicals as well, okay, but then you will never able to relate with those commands properly. So it's up to you. If you want, then because when we are going to cover the Docker, there will be commands, okay. Now what happens in the backend, if you are not clear, then those are just the commands, okay. So what's happening in the backend, first try to understand that and then go to the practical part. Don't rush into the practicals without understanding the theory, because it you will never understand what's happening in the backend. That's a simple command, it's not showing you anything, okay. All right, so let's come down to the remote repository. We already know the remote repository is required for multiple people to collaborate between themselves. So everyone develop on the machine in their local repository and push it into the remote repository. This is how the Git works. So we need a remote repository, okay? And the remote repository that we are going to cover is GitHub, okay? Now GitHub is the most famous public repository. Up till now, it was a public repository, but uh, some time back they introduced the private repositories as well, okay. So now you can create as many private repositories as you want as you can public repositories, okay. Up till now GitHub was used to track the large amount of open source software, okay. So all the open source software, their development files, everything was being committed inside the GitHub, okay. That's how the GitHub got so famous. Another very famous product of is the Atlassian's Bitbucket. Okay, that's also very good and similar to the GitHub. But the major difference was that the Bitbucket used to provide the private repositories and GitHub used to provide public repositories. What is a public repository? A public repository is the one where anyone can see the files, code files. Okay, whatever there is the code, okay, you can view it. So that's a public repository, but GitHub supports both private and public. If you are creating if you are creating a private repository, then you need to have the access to that repository. Then only you would be able to see the contents of that repository. Okay, if you are not having the access to that private repository, you won't be able to see the code. So it's possible to create both the private and the public repository. But the private repository is having a set of limitations, like only 4 people can collaborate inside the private repository if you are not buying the license from the GitHub, okay. If you have purchased the license, then there is no restriction. As many people as you want, they can collaborate inside the GitHub. The major advantage of using the GitHub or Bitbucket is that you don't have to look out after the administration of these repositories. Now, why the administration is a challenge? See, what happens is all your uh, automation, okay, like all the automation in the backend, your CI/CD stuff, build and release part, everyone is calling the remote repository. Okay, so lot of bandwidth is being required depending upon your code base and your repository. Large amount of traffic is being registered on these systems, and there is a necessity that this should always be available. Okay, so if you are using the GitHub and Bitbucket, you don't have to worry about the availability. The companies, there are external companies which are managing the availability for them. Okay, so they have deployed an architecture which will always be available. But the downside is it's a publicly available. Okay, so there are some challenges for the some type of companies to put their code on this. Okay, so they can create their own repositories like GitLab. Another thing is, but the Bitbucket allows you to whitelist the IP. Okay, so only the whitelisted IPs can access the repositories. That adds a security in these repositories. Okay, all right, so how you can sign up for the GitHub at github.com. Okay, you just need an email address and they will send you a verification code, verify your email, and that's it. You are good to create a new repository. So you can click on the new repository on the top right hand side of your GitHub. Okay, and start by creating a new repository. Okay, and you can provide your repository name and a description about what this repository is. Okay, and it provides you an option whether it would be a public repository or whether it would be a private repository. So depending upon what you want to choose, you can create any type of repository and you won't be charged for that. Okay, okay, so public repositories are free, and the at the time of creation of this slide, the private was not free. Okay, it was a premium, but now the private is also free. Okay, so you can create both the public and private, but private repository is having a restriction on it. Okay, so if you want to overcome that restriction, you can buy the license for that. Okay, now once you have done this, okay, it provides you with the origin. This is a remote URL. Okay, so you can add the remote to your existing repository. If you are having an existing repository where you were working on the local repository, so you can add a remote origin inside that repository. Okay, using the git add remote origin command and the remote link. The remote link is the one which is shown in this diagram. Okay, if you will see, this is the remote link. Okay, and you have two options. One is HTTPS, another is SSH. What are these? So what happens is, if you are using an HTTPS option, then every time you push the code inside this repository, okay, you will have to authenticate using the GitHub credentials. Okay, this is the symbol for GitHub. You will always have to authenticate, and when you authenticate, you will have to provide your username and password. Okay, and so each commit you will require to authenticate using your GitLab username and password. But this is something, it will become a headache if you have multiple amounts of commit to be done. So what you can do is, instead you can use the SSH. Okay, and if you are using the SSH, then you will have to provide your key. Okay, public key inside the GitHub. Okay, you will add your key. Once you add the key, okay, it will automatically verify the key, and you are having a private key on your system, so it will not ask you for username and password, and you would be directly able to push the code inside this repository without providing username and password. Okay, and it is more secure, okay, than to provide the username and password. Why? Because the key is 256-bit long and it's an encrypted key, so it's everything is being secure about it. Okay, all right, so how can you push? See, by default the git comes with one branch, that is master branch. Okay, so you can push to the origin master branch, the code, whatever you have created, you can push it inside the master branch. And you can push something like git push hyphen u origin branch name. If you don't want to push onto the master branch, then you can create some other branch and push there as well. Okay. And similarly, tags can also be pushed. Git push origin tags. See, origin is nothing but the branch where you want to push. Okay, so it will tell where you want to push. You can have a remote as git lab or bitbucket or something like that. That's your origin. Okay, so you can push the tags over there, then your tags will be visible inside the GitHub as well. Okay, like that. You see in the image below, it's showing version 1.3, the tag ID. Okay, like that. And all the changes would be seen, whatever be on your system, like how many commits you have done, what number of branches you are having. Okay, at what time the commit was done. Okay, the commit IDs, the branch name, everything is there. The commit was done, what, who has done the commit, this is the metadata. Okay, the basically the message which was added by the user. Okay, so it's showing that the latest commit, it's showing the date, is showing, like that. So all the information from the git, your local repository, is captured inside your remote repository, like that. Okay, so git automatically does this when you push inside your remote repository. While working copy will be the origin, right? Yeah, so Sanjay, when you are right now working, it's on only on your local. Okay, so everything is on your local repository. Unless and until you add a remote to your local repository, everything will always remain in your local repository. Okay, all right, so this is how you can push all. Git will track all the information inside your remote repository. And GitHub allows you to directly create the files and the folders inside the GitHub without actually going to your local repository. So you can click on create new file. Okay, and provide a path to your file, like this is a file which we are providing inside our repository. Okay, so it will go on create this file directly, and afterward ask you for a commit message as well. So you can directly edit the files into the GitHub, but that's not a good practice and you should not follow it. Okay, here is the commit message. It is asking after adding the file. Okay, so everything remains the same. In the backend, git is only working, but this is done through a UI, but it's not a very good way of committing the files and working with the git. And you can check the remote using the git remote -v. It's possible to change the remote anytime. You can run git rm remote origin. Okay, that will remove the origin that you have previously set. And you can git add remote origin and the origin name, then it will add the origin where you want to push. Okay, so it's possible in the git to change the remote whenever you require. All right, so git fetch origin copies all the changes from your remote origin onto your local repository. So all the branches, etc., which has been there on the remote repository will be applied to your local repository as well. Okay, but fetch doesn't affect your present working directory where you are already working. Okay, now git pull origin will pull the latest code from the origin branch to your local branch where you are working. So if you want to pull the branch like code from the master branch, then you can do something like git pull origin master. It will pull the code from your origin master branch to your current branch in which you are working. Okay, let's talk about the branches now. Okay, so this is really important. Okay, to understand the branching strategy. Okay, so by default, see, what happens is you can isolate the code using the branches in the Git. So what happens is, let's say we develop a branch. By default it comes with a master branch. Okay, remember, this is one branch which Git creates for you by default. You don't have to create a master branch, it will always be created by default. Okay, so you start with a master branch and you put all the code here. Okay, now we were developing some feature. Okay, so now if we directly make the change, let's say inside here. Okay, so it's possible that our production will be affected. Okay, so our production code will directly get affected, but we don't want that, right? And let's say there are 20 developers, and if all of them are making the changes into the master directly, then who knows what works and what not, and your entire production will be down. Okay, so what we want is, we want some strategy where each individual can work on the same code which is like the master branch. Okay, but the master should not be affected unless and until someone has reviewed their code and see the changes are working fine. So what we can do is, we can actually create a branch out of master. Okay, like we have created this new feature branch. Okay, so this feature branch has been created from the master branch. Then we can again, from this master, we can create one more branch like the user. User can create a branch from his own name to track all the changes that he is doing. And then we can create some one more branch like something like a dev. Okay, so dev represents your dev environment. Then we can have something like a stage. Okay, and production, we are already using the master branch, or we can even create a prod branch. Okay, now whenever you create a branch out of the previous branch, then all the code which is into this branch, okay, in the master branch, all the files, folders, everything will be available in your new feature branch. Okay, but whatever we do inside this new feature branch, okay, that won't be available into the master now. Okay, so what's happening now is we are working on our own branch. Okay, in isolation. What is isolation? It means that whatever we do inside our feature branch now, that's not going to affect the code which is running on the master. Okay, and we are having the exactly the same code from the master. Okay, into the feature branch, but we can work inside our feature branch without affecting the master branch. That is what the branching is. There are different ways of creating the branch. Like if you are working inside, you are 10 users, you can have a user based branch, so everyone knows what's the other user is working and things like that. Then you can have and branches on the basis of different environments. Okay, these branches can have the code for those different environments like that. Okay, so it's also possible. Okay, Samiksha, when we talk about the origin is nothing but the remote repository. Okay, so it tells you where you are using, because Git needs to know where what is the remote repository you are using. Okay, so you will provide an endpoint like we did in the GitHub. Okay, so that's an origin for the remote local repository. Origin simply denotes that we are, for our source of truth is not the local repository, it's the remote repository, and we are going to push everything inside that repository. So if anyone whatever changes that we are going to do, we are going to push inside our origin from which our local repository has been created. Okay, if you remember the architecture diagram, there I explained you about the source of truth, it lies inside your remote repository. That's what your origin is. Okay, no, Vishal, fetch command doesn't override the pull, and doesn't make the changes. It just it's possible that you have created a remote branch. Okay, then it's not existing inside your local repository. So if you run the git fetch, it will create that branch in your local repository as well. I will show you this in the lab. What we will do is we will create a branch inside the GitHub, which will not be available on your local repository. So if you want the same branch to be available on your local repository, then you will run the git fetch. It will copy that branch from the remote onto your local repository as well. So it basically syncs the state of the two repositories to be exactly the same, not the code, the only the remaining of the things. Okay. All right, so this is your branches in the git. Okay, now once we are here, okay, let's say we were working in isolation and we develop our code. Okay, so what's now? See, the code is right now live in prod. Okay, so once we are done with our coding, what we will do is we are going to merge this branch with the dev branch. Okay, now what the merge will do is when we merge our code, okay, so merge will copy all the files from uh, feature branch into the dev branch. Okay, once we have tested this inside the dev branch, okay, everything is working, then we can merge it with the stage branch. Okay, and finally we are going to merge it with the prod branch, like that. Okay, so you see branching allows you to easily work on your feature, and later you can merge it inside the prod branch after testing and everything has been done. So once you are ready, you can easily merge inside the prod branch. Now, if this branching feature was not there in the Git, then you would have made all the changes directly in the prod, and that could have made the prod down. And this is not a very good way of working because it's not allowing you to test. Another thing is, uh, you can, if even your code is not completed, okay, let's say it's not completed right now, so still you can push everything inside your feature branch, because this is the work in progress. Okay, and you will not lose the code, okay, which you have pushed into the feature branch. And you know that you are not going to apply the merge until and unless it's completed, right? It's in isolation, so it's not affecting anything. So branching is clear to everyone? Anyone having any doubts in the branching? Okay. See, whenever you are merging, Sanjay, let's say we merge the feature branch into the prod branch, then all the files and folder from the feature branch are going to move from feature branch into the production branch. It's not necessarily going to override anything. Like if we are writing the overriding the code, that it's fine, it will show everything during the merge part. When you open a merge, like what changes is being applied, okay, you can review all the changes. And once you are satisfactory that the merging, everything is working fine, then you can go ahead and merge it. Okay, another thing is, always you are going to merge the code inside the remote repository. Okay, you can merge on your local repository as well, but there it doesn't give you an option to see all the changes and things like that. Okay, so I mostly in all the companies you will see that merging of the code is being done on the remote repository. Okay, Sridhar, can you tell me like what's your confusion is? See, whenever you are working, you don't directly work on the production branch, because you are not sure whether your code will work or not. And if 20 people are working, then it will be even more complex, right? So branching solves this. It copies the same code onto your branch. Once you are done editing on your branch, you can merge your branch inside the production branch, and then your code will be live. Anyone having any difficulties in understanding these branches? Yes, Janish, so Janish has a question. So under any of these branches like feature branch, dev branch, we generally create resource specific branches also. Yes. So there are different strategies. Okay. You will see some organization create on the feature basis. Okay, so that all the code related to that feature is inside that feature branch. Okay, and once the feature branch, like the feature that they wanted to introduce, has been completed, okay, they are going to close this branch. See, once the final development has been completed onto a feature, like we wanted to introduce the video sharing in the WhatsApp. Once we have done with the coding, okay, we are going to merge that code inside the production, and now it's live, everything is working fine on the feature branch for video sharing, right? So we are going to close that. Okay, that's called the feature branch of strategy. Another one is in DevOps. You will see usually people will create the branch with their own name, so that just to specify that they are going to work in that branch. That is also one of the strategy, not very effective way of working, but yeah, you can do that as well. Okay, then each of the task which is being reported, you can create a branch on basis of those tasks as well, to track what changes you have done for that task. This is normally done when you are integrating the Jira. Okay, Jira is where you are going to get a task ID. So there is a Jira ID everywhere. Okay, so you can easily track who has requested those changes and what changes were being made. So during the commit, you can provide this Jira ID inside your commit message, and then it will show in the task as well. Okay, so this type of integrations are also there, so you can see like why that changes was being made in the first place. Okay, so you can follow any of the strategy, and then there are branches for each environment. Okay, that's also one of the strategies that is being followed. All right, so let's move ahead. Here is a branching strategy for you. Okay, so you will see that there are multiple commits. See, master branch is created by default. Okay, so you are having the multiple commits, and at this point a new branch has been created out of it, the test branch. Okay, the test branch, and you are doing the commits. These commits are in purple, so they are in only the test right now. Okay, they are not available inside your master. Okay, if you want this to be inside your master, then you will have to merge between the two. Okay, and similarly you will see that after these commits, okay, so there is a new feature branch being created. Now this feature branch will have all of these four commits. Okay, but it will not have this fifth commit because the branch was created here. Okay, and these two commits are not inside your master branch because we haven't merged that. If you want them to be available in your master, you will have to merge this. Okay, you have to merge that at this place, then only these will be available in your master, like that. So this is how the workflow for the Git flows with the branching helps you to isolate everything, so it makes it more simpler for you to uh, manage your code. Okay, and you can easily develop your code on the basis of the feature. Everything would be in one place, so you know what files you have edited for adding that feature, who has edited, everything is being tracked, right? So it act as a project management as well. Okay, now if you want to create a branch, you can put git branch name, whatever branch that you want to create. So it will only create the branch, it will not move you from the master branch to that branch. if you want to switch from the master branch to the branch that you have just created, you will have to use the checkout option for that. So you will do something like git checkout hyphen b, oh sorry, branch name. And let's say you want to combine this, that in a single command you are able to move from the master branch onto a branch which is not existing right now, but it should be created and you should move to that branch. So you can add a hyphen b option here. Okay, just a second. You can add a hyphen b option here. Okay, then in that case it will create the branch and move you from master branch to this new branch. Okay, that's also possible. Like here. Okay, so this at this, if you run this command, okay, it's going to create the branch and going to change you from master branch to this newly created branch, whatever name that you have provided. Okay, it will change it to, let's say, the feature branch in single line of code. Okay, single command. Another thing is, if you want to list all the branches, then you can run the git branch. Okay, it will list all the branches that are available inside your repository. Okay, next comes your merging. Okay, so let's say if you see this example, you can have a feature branch. Okay, there is your feature branch. Then you can have your dev branch. You can have your user branch. Okay, and finally all of them are going to merge inside your master branch. So you can develop according to your requirement, and finally you are going to merge everything inside the master branch again to make your code live in the production. So that is one of the strategy of merging that you can follow. Okay, in previous diagram I am in test branch, and to switch to feature branch, do I need any access, or I can directly switch using checkout? Sanjay, you can directly switch using checkout command. There is no such thing like you don't have to provide any access or something like that. Okay. Are we going to cover merging access and other access grants? Yes. Pratik, we are going to see how we can do that. Okay. So let's say if you have to merge a branch, okay, then how do you do it? So the very first thing is, if you have to do it, okay, this is assuming that you are on the master branch right now already. Okay, so if you are on a master branch, then you can issue this command like git merge and the branch name. So let's say if this is your feature branch, okay, then it will merge all the files which are available on your feature branch into the current branch of master. Okay, that's one way of doing it. Other way of doing it is like git merge the source branch. The branch, this would be your source. Okay, where you are having the new feature, okay, or additional code, and then comes your destination to the branch where you want to merge, like this can be your master branch. Okay, so any of the way is correct. If you are directly on the destination, then you don't need to provide the destination branch again. It's understood that you are going to merge this branch into the current branch, okay, which is your destination branch. And if you are not on those branches, you want to just merge the two branches, then you can use like this git merge the source branch name, it can be your new feature branch, and the destination branch name, it can be your master branch. Okay, clear to everyone how you can merge? But normally you are not going to merge like this. Okay, merge requests are normally open in the GitHub. Yeah, Pratik, you can do that as well. Git merge master and the destination branch if you want to merge the master branch code into your own branch. Okay, but what happens is you create a branch. Okay, and you once you have created a branch, instead of merging the code, okay, what you do is you pull the code from the remote origin, like you do git pull origin master. Okay, so it will pull all the latest code of the master branch into your branch that you have created. So once you have created a branch, you are going to pull the code from the master branch into your branch. Okay, instead of merging, you can do that, but that's not a common practice. Pulling from the master branch is a common practice. All right, let's talk about the conflicts. Okay, so how the conflicts come. So whenever we talk about the conflicts, okay, usually what happens, you are going to uh, take a create a branch one from the master. Let's say in this case we assign a value of 1. Okay, so this will work. Okay, and then we assign a value of 2, so that will also work. Okay, because same user is putting these values, right? So this will not result in any conflict. This is perfectly fine. Okay, he's issuing the first commit over here. Okay, this is the first commit, let's say. So he's assigning a value of 1, and this is a second commit, so he's assigning a value of 2. So this condition is perfectly fine. Okay, now let's talk about this condition. Let's say this is user 1. Okay, and this is user 2. Okay, he assigned a value of 1, and he assigned a value of 2. See, now both the users has assigned a different value. Okay, and both are trying to merge. So what will happen? The user who first merges his code, okay, he will go through, let's say this one first merges his code, so a1 a equal to 1 will be accepted. But when a second user tries to merge the code, okay, he will get an exception. Okay, he will get a conflict basically, and he won't be allowed to merge his code. So what will happen is he will have to pull this code. Okay, so whatever commit id was issued over to the user 1, okay, that will come down to the user 2. At this point the user 2 will be aware that the user 1 has assigned a value of 1, a equal to 1, to the variable. Now this will they will have to decide between themselves whether a is equal to 1 or a is equal to 2. Whatever be the value, then they will have to create a new commit overriding the previous commit. Okay, where a equal to 1 was decided, then he has to override it, and then that issue will be resolved. Okay, so this is how the conflicts are being raised. Okay, and you will have to resolve the conflicts like that. So once you pull, Pratik, it will automatically get merged into your local branch. When you do git pull origin master, all the changes from the master branch will be pulled and merged inside your local repository. You don't have to specifically merge them. I will show you. Okay, this will become more clear to you at that point in time. So let's say after you are done with the branch, you can delete the branch. You should always delete the branch once the work is over on that branch. Why? Because the branches are having the exact copy of the code from the source branch, right? So if we created a new feature branch from the master branch, okay, then it has all the code from the master branch. And now we are done adding the new feature. okay, and we are not going to work again on that branch because the new feature was added and its code is now inside the master branch and it's lying redundant over there. Okay, so the issue is if you don't delete that branch, your repository size will increase very quickly. Okay, it will multiply each time you create a branch and don't delete it. So once the work is completed on your branch, you should always delete it. Otherwise your repository code will be very big. So when the later the user comes in and joins, okay, your coding, then he has to wait for a very long period of time before he can clone the repository. Okay, that would unnecessarily complicate the things. Your CI will run slow, okay, and things like that. So it's always better to delete the branches once you no longer require them. So you can delete a branch using git branch -d and the branch name. Okay, and let's say if you were developing something and in the middle of it that project was scrapped and you haven't merged your code inside the master, but that functionality is no longer required, so you can delete the unmerged branches using -D. Okay, that's a difference between the small d and the capital D. Small d is used to delete the merged branches, capital D is used to delete the unmerged branches. And here is another example of the conflict for you. Okay, now if you will see this conflict, what's happening is this is your remote repository. Okay, this is your remote, and you will see the code is here. It's on the third line. You will see it's having a value of ljkl. Okay, and this is a user one. Okay, let's say this is user one, this is user two. Okay, at that point both have taken a pull of this from the remote. Okay, and he has edited the same file with the value of xyz. Okay, wxyz, and he has replaced ljkl with qrst. Okay, now the problem is both of them had edited the same file and both of them had changed the same line of code with the different values. Now it's not possible that the same line, same file can have different lines of code. Okay, and the same, exactly the same line number. So that's an issue. Now whosoever is going to commit first, let's say he first commits it. Okay, so his code will go through. Okay, and this will work fine. And he commits second. Okay, so he will receive a conflict because at that point in time that value was already assigned and he is not aware about it. Okay, so git will track this and it will raise a conflict to this user. Okay, at this point, again, what he has to do is he will have to take a pull. Okay, this value has been overwritten. Okay, now this value would have been overwritten with w x y z. Okay, and this now he will see that his qrst is being replaced by wxyz when he takes a pull. So and he will also get, if he run a command called git blame. Okay, if it runs git blame or if he checks the remote repository, then he will see that this user has done the change. Okay, then he has to contact this user. Okay, and understand why he has assigned the value of wxyz. Okay, instead of qrst. If both of them agrees that this should be the value, then it's fine. Otherwise he has to change. And if both of them agrees that qrst should be the value, in that case this user will uh, again issue a new commit. Okay, after taking the pull, he will issue a commit replacing the WXYZ with QRST, and he would override his code. Then this conflict will be resolved. Okay, this conflict will be resolved and it would go through like that. This is a strategy that would be followed to resolve the conflict in this case. Yeah, so Sujit, this normally happens like this only. Conflicts are happening because multiple people are trying to assign different values onto the same thing. Okay, and this is very common. Okay, although people don't do it intentionally, but this happens, and Git is able to track this, so it maintains the consistency of your code. Otherwise, if Git was not there, okay, Git doesn't raise a conflict, then anyone would have written overridden the value of anyone else, and though two people won't have collaborate. This is a very common issue that you will see can happen when multiple people are collaborating to write a code. Okay, will Git didn't throw a notification that another user is already working with the same file? No, Vishal. uh, Git is not blocking the users. Okay, they will only see this condition when they push their code inside the GitHub. Okay, GitHub is not polling their local repository again and again to check if this is happening or not, and it doesn't make sense, right? So you can't wait on the notification. He might have changed MNOP. Okay, and he would have changed EFGH. So that would not have resulted in any conflict because they both were working on different line. Although they were working on the same file, but they were working on the different file or different line. Then this would not have resulted. So when we do branching or commit, is the email sent out to particular user or all the user emails ID is working at the same master branch? Guys, Git has nothing to do with email. Okay, it's not sending out any notification. That is not the work of the Git at all. Okay, users have to keep a track of what the other users are doing. They are free to work as they like, and whenever a conflict comes, he would be notified why the conflict is coming. Okay, Git will show them. I will show you how the Git actually shows those conflicts, and then he can collaborate with the user one who has initially placed that change. Okay, because he has made this change, so user 2 can contact user 1, and both of them can decide what should be the value, and final value what they decide, they could make a commit to that. Remember, Git will not send any notification that he is working on this branch or he is working on that branch, and they like that. Okay, okay, so I told you how they are going to resolve the conflicts. Okay, here is another example. Okay, of the file. You will see the conflicts conflict here is because he has changed this value. Okay, inside branch 1, and he has changed it to feature 1. Okay, that's why this conflict is coming. Now once he have pushed merge his changes, ideally this user should have taken a pull. Okay, and once he has got the latest code after he has merged it, okay, then he should have changed it to feature 1. Then there wouldn't have been any conflict, but because he didn't take the pull and he is working on the old copy, that's why the conflict is coming. Okay, so it's almost the same type of condition. Okay, always conflicts happens like this only. Okay, so two people can sit together and remove the conflicts. Now next comes your stashing. Okay, So consider an example, like let's say you were working on something, on some feature, and after some time, the you have written a code for that feature, okay, and then the business team comes to you and says that feature is not required anymore for now, okay, or it has been deprioritized, okay. Now you know that this will be picked up after some time, okay, and you have already written a piece of code, okay, so you can't delete it, okay, and you can't commit it because it is not finalized yet. So what you can do is you can use git stash command, okay. The git stash is going to stash all the files, uncommitted files, okay, which are in your staging area, to a temporary location known as stash, okay, and that's a temporary location so that you can switch on to other branches, okay. So it will allow you to stash the area into some temporary location, and it will not show you any of the files or folders like that once you stash them. Then after like 15 days it again gets prioritized, so you can use git pop stash, git pop command, and it will bring back those files and folders for you, okay. So if you just temporarily want to stash a file for some period of time that you don't want to look at, okay, so you can use the git stash command. So you can stash using git stash command, and you can put a save and the message to understand why that stash was being created in the first place, okay. And if you want to see all the stashes that was being done, so you can do something like git stash list. It will list, if you are having the multiple stash in your environment, then it will list down all the stashes, and you can verify from that which stash you want to recover, okay. And so Jarish, usually what happens is even you might have to stash sometime. Let's say you were writing some automation, okay, and uh, that was like that task was blocked for some approval or something like that, okay, and you have written the code, okay, but you haven't tested it, and there is some production issue, and you have to make some other changes, okay. So you are not going to delete it, right? There is some other high priority task which has came to you, so you can apply a stash, okay, and later when you resolve the production issue you can come back and pop that stash and again work on your task, right? Otherwise you will have to delete it and recode, so that doesn't make sense. So that's why uh, you can apply the stash, okay. You can apply uh, the stash to the uh, saved stashes as well, so you can something like git stash apply stash id, okay, so you can even do that. And when you want your files to be back, so you can run this command git stash pop. It will pop up all the files and folders which was stashed in first place, okay. And if you want to just recover some particular stash, let's say we are having 5 stashes, and each stash will be having a particular stash id, and if you just want to, let's say, recover the third one, okay, not all of them, only the third stash you want to recover, so you can or you want to drop it, let's say it was not deprioritized, it's not required anymore, okay, so you can drop it now, so using git stash drop and stash id, uh, okay, that will drop the stash completely, okay. And if you want to clear all the stash, like all the things that you previously stashed are no longer required, then you can run git stash clear. It will clear all the stashes from your system. Nitish is asking, is stash similar to VSTS shelf pending changes? I'm not aware about the VSTS, Nitish. Uh, I'm using mostly Git, okay? So I'm not sure about the VSTS, so can't comment on that. All right, next comes your rebasing, okay? Now this is one of the thing which I haven't seen DevOps implementing any time, okay? This is something which should be done with the utmost care, and I don't find any situation why you want to rebase, okay, in a practical world, okay. So what happens is, let's say uh, you were working on a feature branch, okay, and you applied some commits, okay. So you applied these two commits, and later on what happened is you deleted this branch, or this is becomes non-functional over a period of time. You created another branch, okay, and you added the commits inside that. So these were the original commits, okay, but over a period of time you merge these two branches, okay. And so originally what will happen is this would come first, okay, your old commits would come first, and then your new commits would be there, like that, okay. But you initially started on this branch, okay. This is your first branch that you started, although the development continued onto this second branch, okay, and later on you merged inside that first branch into the second branch, okay. So these commits, okay, these commits were later done, okay, and these were done earlier, okay. If you merge them, what will happen is the later commits will come first, okay, and earlier commits will come second. So this is not a, you see, this is a problem. Why it's a problem? If someone is tracking some changes, okay, the earlier commits are tracking later, although this was done earlier, okay, it's coming later, and this is coming earlier, okay. So let's say we might have created a file in this point, okay, it's coming later, but we might have already edited the file. If someone is seeing the history before, so what he will see is that someone edited the file before creating the file. So that's not practically possible, you see. Logically it's not possible that before create you first edit the file and then create a file which you were editing. So what would have happened is first you would have create a file, okay, and then you have edited the file. But right now what's happening is you have edited the file because you merge it inside that branch. So it's showing that edit of the file was done previous to before creating the file. So that's a logical issue, right? Now what you, the rebasing allows you to rebase the two branches. So if you do that, so these commits would be removed, okay, they will no longer be like this. Instead these initial commits that you initially done, this would be placed at the starting of the branch, okay. So now it will become like this, that this was done first, okay, this will be placed at the top of the branch, okay, and then this will be placed at second. So now it's logical that the file was created earlier and then you were editing the file, okay. Did everyone understand rebasing? Rebasing is only required for the developers. All right, just to repeat, okay. So what happens is, uh, let's say we were initially working on this branch 1, okay, and this is your branch 2, and then we created two commits over here. These were the first initially done, and this was done later, okay. This is the branch 2 commits, not the yellow one, only the purple ones, okay. Now later on we merge the b1 into the b2, okay, so this become our feature branch, okay. Now if we do like that, okay, what will happen is, the feature branch is having these commits, okay. Now these two commits would be placed here, okay. And just for your exam understanding, I was saying that it's possible that we might have created a file, okay. We have created a file, and then we have edited the file, okay. So at this place, if someone will see the commit history, what he will find inside the commit history is that we have edited the file before creating a file. So that's logically wrong. So developers needs to correct that, okay. Sometimes, although I haven't seen from the DevOps perspective this happening, okay, but this is something which developers needs. So what they do is, they rebase it, okay. When they rebase a branch, so these two commits, instead of going here, okay, over here, it goes at the start of the branch. You see, they are at the start of the branch now. These two are representing the commits over here, and then your later commits are following in the purple one, okay. So now it's serialized. Initially the file was created, then it was edited, so everything is fine now. So that is the purpose of rebasing. Let me know if still someone is having any problem in understanding this. It is used just to arrange the commits in a serialized way, okay. So the commits, which was the sequence of the commits, can be preserved, okay, if you are merging the two branches. But this is very, I would say, an ideal case scenario where you are going to do that. Normally rebasing is not required. Instead you can just merge it, okay. You don't have to rebase it. This is done if you want to preserve the commit id history for the git log, for some later someone can understand how this was being done, okay. All right, so why the rebasing is being done? To provide a clean history, okay. So if you are, that's from a developer's point of view. For the bugs, if someone is viewing it later, then they will have a clean history of how the commits was being done, okay. Otherwise there can be the issues like we just notify, I just that the editing of the file was done before creating the file, so that's not possible, right? That's why, to maintain a clean history, rebasing is done. All right, so here are the options for integrating your code, okay. Now instead of uh, rebasing, okay, you can actually merge directly, okay. And so if you can directly merge between the feature branch and the master branch, that should sort the problem out for you. But it's possible that you first rebase and then merge, okay. So how do you rebase? You rebase by git rebase and the branch name that you want to rebase, okay. Then it will rebase, it will took those commits from the remote branch, put it at the starting of your branch, okay, and then whatever commits you were already having, that will become after the commits from the remote branch has been added to the tip of the branch. Okay, so just for your understanding, let me show you. If this is my branch 1, okay, it is having two commits. One is this, another one is this, okay, and here is my second branch, which is having this commit and this commit. Okay, so if I'm on this, okay, and I say git rebase, okay, git rebase 2, okay, so what will happen? So my first branch will look like this now with the commits. So clear to everyone how the git rebasing works? It's just to manage the clear history, okay, of the commits, in which sequence the commits was being done, okay. But this is for the developers, okay, or not for, mostly I haven't seen any use case in the DevOps. All right, so how do you revert a commit? Okay, see, it's possible. Up till now we know that commits are permanent, okay, but you can revert the commits as well, okay. So let's say you go from C1 to C2 and then from C2 to C3, okay, but somehow there is an issue with while going from commit 1 to commit 2, okay, this is not working in actual. So instead you can revert back to C1, okay, and directly go from C1 to C3, okay. So you can undo the changes, okay, to your previous commit. Let's say we are here, okay, so we made this commit, okay, now we don't want this commit, okay, but it's there right now, okay, so we can use the git revert command, okay, and we can provide the commit id of C2, okay, so we can provide the C2 commit id. Then what will happen? It will revert back to C1. Our code base will revert back to C1, okay, it will revert back to C1 now. So git revert reverts the commit back. If this is normally the case uh, when let's say some of the changes that you have done is not working in production, okay, so you will see that in case of nginx or web servers, whenever you made some changes and it's not working properly on the production, okay, there is some issue, then you can easily revert back to the previous commit. This is allowed. That's how the revert works. All right, last thing is git reset, okay. Sanjay, not the previous local version, okay. uh, See, right now if you are working on the local repository, it will revert back to the previous commit which is on your local, or if you are even on the remote, then it will revert back to the previous commit on your remote, okay. So you can revert back uh, as per your history, okay, what was your last commit, okay, you can revert back to that commit. So Manoj is having a question. Let's say we have three users. They committed the code to the same Jira ID. Okay. So normally, Manoj, you will want see that only one user is working to each Jira ID. Okay. But let's take your case that three users were working in on a Jira ID issue with only one user's code. Now, Manoj, there is one catch over here is that whenever you can have multiple commits, but before merging, okay, into the production, you can have a review as well. So if someone was having some issue, then it would have been tracked inside the review as well. Okay, but let's say somehow the review was not being done. Okay, if we do revert with the Jira ID, it will revert all the code which was committed. Now, Manoj, normally the practice is that you will revert the entire code. Okay, and it's already in the another branch, so you can fix your code over there. Okay, I haven't seen like people reverting each commit id, because the chances are that the code was having entire code base was having some issue. Okay, so normally you don't revert on the commit basis. In that case, you will revert back, you will to the entire code which was previously there. Okay, so you revert back to the previous commit id which was working. Now there can be multiple commits before the merge has happened. So let's say there is 7 to 8 commits was there. Okay, so you will not revert back to the previous commit id only, but instead you will revert back to what was last commit which was working. Okay, once you revert back to the last commit which was working, okay, everything will be working again. Only your changes would have been removed that the user has introduced. Then it becomes the responsibility of the user to actually sort that out. Okay, whatever code he has written that's not working, so they will have to figure it out and then fix that and then again merge it, like that. Okay, all right. Just like the git revert, you can use the git reset as well to undo the changes at different levels. Okay, now if there are different modifiers which are available for the git reset command. Okay, git reset is also used to revert the commit ids. Okay, now the important thing to understand with the git reset is the modifiers that you are going to use. If you are going to use hyphen hyphen hard, then all the references to that commit id will be removed. Okay, so do this very cautiously, because this actually can create issues with your history of the commits, how it was being done. Okay, so someone else might be seeing in his local repository that there was a commit id, but when he checks the remote and other users, it might have been not there. Okay, this happens when someone has reset hard. Okay, in which case reference to the commit id has been removed entirely from the git. That commit id never exists. Okay, so hard is for that. You should always use hyphen hyphen soft. Okay, that should that will allow you to actually see what was reverted. Okay, it will keep a commit, but it will show that some reset has happened, and then you can use the mixed as well. Okay, and let's say in this case what's happening is we were moving from c1 to c2, then c2 to c3. Somehow on reaching c3 we see that there is a problem, so we can provide the commit id. Okay, uh, to which we want to revert. So we will provide a commit id of c2, and then whatever be the commit id over here, okay, of c3, it will revert back to the c2. So in git reset, if even I want to revert back to c1, I could have provided the commit id. Okay, and then it would have revert back to that commit id. So git reset allows you to choose the commit where you want to revert back. Okay, so that's all from the git side. Okay, and not much of the time is left now. Okay, it's almost completed. So in our next session, we are going to do the lab for the gate first. Okay, it will take around 30 to 40 minutes to complete with the lab. Okay, once we are done with the lab, then we are going to start with the Docker containers the same day. Okay, anyone having any questions, any doubts? All right, so for the lab you just need Sanjay one VM. Okay, with Linux installed on that VM first thing. Okay, and we will install the git using the package manager. So for installing git you just need to run yum install git. That's it. It will install the git for you. Okay, and you don't need anything else. Okay, Abhilash is saying. So Abhilash, I answered that question. Okay, so we are going to install the git, and that command will install the git for us. So nothing else is required. Pratik is saying we are not able to see any of the PPTs in LMS. Pratik, uh, PPTs are shared with you in the form of PDFs. Okay, so there are PDFs which are available. So you can review that. If you are not seeing the PDFs in your LMS portal somehow, okay, drop a mail to the Cognitia support that you are not able to see the PDFs in your LMS portal. They are going to make those PDFs available to you in the LMS portal. Okay. Okay. Sridhar is asking to repeat the reset once. So, Sridhar, the reset, git reset command helps you to reset the commit to some previous commit ID. Okay. So you can revert back to any of the previous commit ID using the reset. You just need to provide the git reset. Okay, and the commit ID to which you want to revert back your code. Okay, so if something is not working, like in this case C3 is not working, so we could have provided the commit ID for C2, then it would have revert back to the C2, the state till the C2. Okay, where the things was working. That's what git reset does. So there is only the difference between git revert and reset is in git reset you can select which commit you want to revert to. Git revert will remove the latest commit, and whatever be your last commit before that it will revert back to there. Okay. Avilash, I haven't started with the git installation. Okay, but the problem in your case is you are installing it from the vagrant user. Okay, you need to be the root. Whenever you use the yum to install anything you need to be the root user, so you will have to take a sudo. Guys, when I do the lab with you, okay, perform the lab only then, otherwise you will stuck in problems. Okay. Yeah, you can register on GitHub. Okay, Janish, that's fine. You can go to the github.com. Okay, and create an account over there. That's free, so just everyone should register on the github.com. You can install on the same VM or you can create a new VM. Vishal, it's up to you. Okay, we just need one VM of CentOS 7.5 running. That's it, nothing else. All right, any other question, guys? So just get one VM ready. Okay, just make one VM ready, and we are going to work on that VM from the scratch. Okay, install the git and do everything. Yeah, first of all, in the next class, we are going to start with the lab. Okay. First thing, we are going to perform the Git lab in the next class. Okay. That should be completed in like 30 to 40 minutes. Okay. Then we are going to start with the Docker. All right. That's all from my side. Anyone else having any questions? You can ask now. Otherwise, I'm going to end the session now. Thanks everyone for attending today's session. I will see you in the next session.